Hi to all, welcome to my first class on the topic circles. In this class, I am going to discuss what is tangent and a theorem. Tangent at any point of a circle is perpendicular to the radius through the point of contact. Let us consider a circle and a line PQ. There can be three possibilities. Here, this line PQ and the circle don't have any common point. Then we can say, or in this case we can PQ as a non-intersecting line with respect to the circle with center O. So we can write PQ is called a non-intersecting line with respect to the circle. Let us look at the second case. In this case, this line PQ intersecting the circle at A and B, that is line PQ and the circle having two common points, that is A and B. In this case we can call line PQ is a secant of the circle, or secant is a line which touches the circle at 2 points. Now this is the third case. Here you can see line PQ and the circle having only one common point. In this case, this line PQ we can call it as tangent to the circle. So we can define tangent as a tangent to a circle is a line that intersects the circle at only one point. Here A is the common point of the circle and the tangent. So this common point we can call it as point of contact. So we can write the common point of the tangent and the circle is called the point of contact. Here A is the point of contact. Now let us check how many tangents you can draw through the point A. Let us see. Here you can see so many lines you can draw through a point, but all the other lines intersect the circle at 2 points. So there is only one tangent you can draw through a point on a circle. Now, what about the angle between the tangent and the radius through the point of contact? Let us discuss a theorem. Here, EF is the tangent and OP is the radius. Now you can see the angle made by the tangent and radius through the point of contact is 90 degrees. Now in all the points on the circle, the radius and tangent, you can see the angle is equal to 90 degrees. So we can say here EF is the tangent and OP is the radius. The angle made by the tangent and the radius is 90 degrees. This is true for every point on the circle. That means tangent is perpendicular to the radius through the point of contact. This is a theorem And the theorem states as the tangent at any point of a circle is perpendicular to the radius through the point of contact. Now let us prove it. We are given a circle with the center O and a tangent xy to the circle at a point P. We need to prove OP is perpendicular to xy. Take a point Q on xy other than P and join OQ. Here, Q must lie outside the circle. Why? Q is a point on the tangent. Okay. If Q is inside a circle, what will happen? If Q is inside the circle, xy cannot be a tangent. It will become a secant. So, we can write the point Q must lie outside the circle. Now, what about the length of OQ? Here, you can see the radius is less than OQ, or you can say OQ is greater than OP. So we can write, therefore OQ is longer than the radius OP of the circle. That is OQ greater than OP. Is it true for every point on XY? Let us check it. Here OQ is greater than OP, but here you can see when P coincides Q, both lengths are equal. Rest every points on XY, OP is greater than, OQ is greater than OP. So we can write OP is the shortest of all distances from OT to the tangent XY. So we can write, since this happens for every point on the line XY except the point P, OP is the shortest of all the distance of the point O to the points of XY. And you know that the shortest distance is always perpendicular. So we can conclude OP is perpendicular to XY. This is an important theorem and asked many times in CBSE exams. With this theorem, I am winding up today's class. Have a nice day.